So today we're going to solve polynomials by factoring. So basically the steps are up top. We have to set the polynomial equal to 0. Then we're going to factor it. So on this one I'm going to look for greatest common factor first. And I would be left with x times x squared plus 1 equals 0. And this is as factored as it can get. So at this point I am going to divide my factors and set them both equal to 0. So this one is finished. This one is not. So I'm going to move the 1 to the other side. And then because there's no b value, I'm going to square root both sides, and I would get x equals positive or negative I, because the square root of negative is I, and the square root of 1 is 1. So I could leave it like this. I could put a 1 right here. Either way would be okay. And kind of the more like formal way to write it would be like this. I'll be okay though if we just box in our answers. So that's the first one. Second one we're going to look at is number 3. So I quickly noticed that it is the difference of squares. So I'm going to factor that. Using the rules that we learned, it would be plus 8 and minus 8. And then I'm going to split because I cannot factor x squared minus 8 anymore because 8 is not a perfect square. So I would get x squared plus 8 equals 0 and x squared minus 8 equals 0. So I'm going to start on this left one. So I would subtract 8 to the other side and get x squared equals negative 8. And then I'm going to square root. So I know I would get x equals plus or minus I square root of 8. But I'm going to birthday cake 8 and see if we could simplify that a little bit more. And when we do that, we know we have a group of 2. So a 2 gets to come out of the radical, and this 2 has to stay underneath. So the more simplified answer would be 2i square root of 2. So this one's going to be similar. I'm going to add 8 to the other side and then square root both sides. So it would end up being plus or minus 2 square root of 2. So the only difference is there's no I because there was not a negative underneath the radical. So then we're going to go to an example of the sum of cubes. And so I know these are both cubes. I know my A would be x, my B would be 5, because 5 times 5 times 5 is 125. And so the rule that we learned is A plus B, and then A squared minus A times B, so 5x, plus B squared. And this can't be factored anymore, so we're going to split it. And so this would be x equals negative 5. This one, though, we're going to have to do a little extra work. So when we did quadratics, we learned that we could solve by factoring, which we can't use on this one because it can't get factored anymore. We could solve by square roots, which we can't use on this because there's a b value. And then we have 2 other options, quadratic formula and completing the square. And quadratic formula works every time, so that's what we're going to practice on this one. So my a value is 1, b is negative 5, and c is 25. So I do x equals negative b, which since it is negative, it's actually going to turn to be positive, plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to start by simplifying underneath my radical. So negative 5 squared would be 25. Negative 4 times 1 times 25 is negative 100. So it would give me 5 plus or minus the square root of negative 75 over 2. So I know that I can't have a negative underneath, so I know I'm going to have an I come out. But I'm also going to take a second and birthday cake 75. So 5 goes into that 15 times. 5 goes into that 3 times. And so I see that I could simplify that. So it would become 5 plus or minus 5i times the square root of 3 over 2. And so that is our other answer. And just a quick comment, this is one answer. This is actually two different answers because it would be 5 plus 5i square root of 3 over 2, and then 5 minus 5i square root of 3 over 2. So next we have difference of cubes. So I know my a value is x. My b value of this would be 6 because 6 cubed is 216. And so my rules say a minus b, a squared plus ab, which is 6x, plus b squared. Then I'm going to split that and set it equal to 0. So I have that one. This time we're going to do completing the square because I just want to practice that. So first thing we're going to do is we're going to move the 36 to the other side. Then I'm going to take my b value, which is 6, and divide it by 2, which would be 3. I'm going to square that, and that gives me 9. So I'm going to do x squared plus 6x plus 9 equals negative 36 plus 9. So I added 9 to both sides. Then I'm going to rewrite this as x plus 3 squared. And then whenever you add that, you would get negative 27. So now we're going to square root both sides. So we would get x plus 3 equals, so the square root of 27, if I birthday cake, I know 3 can go into 27 9 times. 3 can go into 9 3 times. So I would get plus or minus 3i square root of 3 because this is still underneath the radical. So then I need to subtract a 3 to the other side, so we would actually write it as negative 3 plus or minus 3i square root of 3. So that's completing the square. So you could use quadratic formula or completing the square, whichever one feels more comfortable to you. Number 9, it is just a trinomial. So I'm going to factor it, and I would get x squared. One of them's plus, one of them's minus because I have a negative c value. And I know my bigger factor needs to be next to the plus sign since my middle term. So I know 7 times 6 is 42. Then I'm going to split these. And when I move the 7 over, it becomes negative. And I'm going to square root both sides. So it would give me x is plus or minus I square root of 7 because it cannot be broken down anymore. This one I'm going to move the 6 over. So when I square root that, I would get plus or minus square root of 6 because 6 can't be broken down anymore either. So we're going to look at another example of a trinomial. This trinomial, first I'm going to look for greatest common factor so I can factor out an x. And I'd be left with x squared minus 8x plus 16. Then I'm going to see if I can continue to factor this, and turns out I actually can. I would get, both would be negatives because my product is positive, and so I would get 4 and 4. And so we actually were able to solve by factoring completely on this one. I would get x equals 0, x equals 4, and x equals 4. Since these are the same, I don't have to write them twice. Just quick review, this actually means that it has a multiplicity of 2, which tells us that the function is going to bounce at that point instead of cross through at that point. So then we'll do another trinomial example. This one, the first thing we have to do is set it equal to 0. So we would have to do 3x to the 4th minus 2x squared minus 16 equals 0. Then we're going to factor out a 3. Nope, we can't because we can't factor a 3 from everything. So in order to factor this, we're going to try bottoms up or slip and slide. So when I get that, I would get x to the 4th minus 2x squared, and then 3 times negative 16 is negative 48. Then I'm going to try to factor that. And I know one would be plus, one would be minus, and for 48 it would be 8 and 6. And so then, because I'm slip and slide, I would have to divide both factors by 3. And since this is divisible by 3, one of my factors would be x squared plus 2. This is not able to reduce anymore, so it moves up, so it would be 3x squared minus 8. So now I have my factors, so we had to do a little work just to get that. Now I'm going to split and solve. So x squared plus 2 equals 0. I would subtract 2, so I would get x squared equals negative 2. When I square root, I would get x equals plus or minus I square root of 2. So that is part of my answer. The other one, when I set it equal to 0, I would add 8, so I would get 3x squared equals 8, divide by 3, so I would get x squared equals 8 over 3. Then I have to square root both. So when I do that, that's the same as square root of 8 over square root of 3, and we cannot leave that as a final answer because we can't have a radical in the denominator. So in order to rationalize that, we multiply by the square root of 3 over the square root of 3, because really that's like multiplying by 1. And when we multiply straight across, it would end up being the square root of 24 over 3, because the square root of 3 times square root of 3. So then I'm going to see if I can simplify 24. And I can. So a 2 could come out. So it would be x equals 2 plus or minus 2. And then a 6 would be left underneath. Square root of 6 all over 3. And so that is our final answer. One more. This one we get to factor by grouping since it has 4 terms. So I would bring out an x squared. That would leave me with x plus 2. And this one I could bring out a 5, and that will leave me with x plus 2. So then when I rewrite my factors, I have those, and I split them and set them equal to 0. So this would become x squared equals negative 5. Square root both sides, I would get x equals plus or minus I square root of 5. This one I would just subtract 2 to the other side, so I would get x equals negative 2. So that is solving polynomials by factoring.